photons are intercepting and photodissociating these deuteriums and the heliums, all of them ultimately become neutrons and protons, and the neutrons don't want to fall into the black hole very quickly because they are not coupled to the magnetic field, but the protons fall into the black hole quickly. So ultimately you get a excess neutrons moving around, and until they decay for after 11 minutes, they then decay they then fall into like a proton. So you can calculate the nature of the neutron disk for a neutron disk. Instead of neutron star, we can have a neutron disk around the black hole, which may in principle produce neutron-rich elements in the outflow. When the outflows are produced from the same barrier, so this is our understanding, we calculated the possibility, it can even produce the deuterium in the outflow itself, because outflow is cooler. So once you fool everybody into neutrons and protons and take them as outflows, outflow can produce deuterium and probably contribute to the deuterium problem that we know today. The next, a few more solutions I wanted to show. Jesus. Very bad, somehow, not meant to be, but so this is a typical case of a nuclear reaction. You take all these elements like a population 1 abundance. Something is wrong with this gadget. Okay, you take these elements, and as they fall into the black hole, you see how this is the logarithmic radial distance. So this is about 8 Schwarzschild radius. So between 1 and the 8 Schwarzschild radius, you start seeing that this abundances changes, the composition changes. But by the time they realize this, of course, they all get into the black hole. I am still hoping that from the wind we can extract some of these isotopes, and should be able to predict that whether we can see some of these isotopes in the outflowing wind or not. We calculate the nuclear energy release, and in fact, when the deuterium and the heliums are being burned, they actually extract energy out of the disk, and therefore the disk gets cooler. You can now put a restriction on how much such is allowed, because if the nuclear energy extraction is much larger compared to the gravitational energy release, then you can see the solution. Instead of becoming supersonic into the horizon, it staggers, including the nuclear energy release. So now you not only in the Q plus Q minus of my entropy equation, if you add the energy release due to the endothermic reaction and exothermic reaction, you start producing new solutions, and which show some kind of small oscillation at the inner sonic point. So this is something again new. The third point is a little bit interesting for only a few people, but too bad that Professor Damour have left. I told him yesterday this in the island. So this is an interesting point. It is in the gravitational wave astronomy, because once you know that the matter is actually falling sub-Keplerian manner, and you take two black holes, let us say at the galactic center a massive black hole, and the small black hole is in a binary, it's like it's falling in through gravitational wave emission. But now assume that there is an accretion disk. Nobody really considers accretion disk in the system, because they think that two neutron stars are falling in, there is no accretion disk in either of them, or a black hole is falling around another black hole, no accretion disk. But in the case of a center of a galaxy, you can have a massive black hole, you can have an accretion disk which is sub-Keplerian at a very large region, and then some neutron star or black hole is falling in. It is now not, let us say, to maximize the effect, in the same plane. So then, when this matter is falling in, it is falling through a sub-Keplerian region, which is accreting sub-Keplerian matter, and therefore, in other words, accreting negative angular momentum, equivalent to losing angular momentum. So that loss will be competing with the loss due to gravitational wave, and we have written several papers in PRD. Last paper I wrote in Physical Review D to show that actually the nature of the gravitational wave emission, the correction that it will introduce is much higher than what people are talking about post Newtonian, or to go to higher Newtonian. And I know that the Keith Thorne, for instance, appreciates this. He cites this everywhere, and he says that if the accretion disk is there, it's a completely different ball game. It is going to change the gravity wave emission. I have some picture. I did not bring any transparency for this, but I hope that this gadget is going to transmit something. So this is the nature with disk and without disk, how the solution So this is how this sharp gravity wave frequency will change with height, with the distance or time. Actually, I wrote here in time in seconds. So for the same system, you will see that this makes a big difference. Actually, the object tends to lose angular momentum much faster than when you add the gravity wave. So and this is not a very bad effect. It could be up to 7% or 8% effect when you have gravity. So when you study this accretion this carefully, and when you find this subcapillary region exists, a large number of new physics will come up, and I think that it will have some more effects.
Thank you, Chakrabarti. Any questions, please?
That is in the double peak has been a double peak. Well, in my case, when I consider non-magnetic situation, there is no double peak. But when the explanation that Leib gave in his first lecture, I liked very much. Probably let me tell very quickly, and Leib can also tell, of course. You have the transparency here. Why? Very quick. Well, I like this explanation. Basically, the same thing is happening, but magnetic field is splitting this thing. You have a magnetic field which is this is this is the magnetic axis, and there is rotation axis. So this accretion disk is there. So this region, this place, this end and this end will have a different radial distance from the, because magnetic axis is not aligned with the rotation axis. You imagine yourself that the upper end of the disk is intersecting here, while lower end is intersecting there, and therefore these two, the outflows that are produced from there, the blobs, will be producing two different frequencies. That was his explanation. But no, without magnetic field I cannot explain the double peak. So Newton star I am not taking much but I am much more worried about the black hole. All I am saying is that within the same framework we can talk about the oscillation of this boundary layer and things like that. But a black hole, since they don't anchor magnetic field, you don't see the splitting. So I am happy. But adding magnetic field, Leib can produce splitting. Yeah, this picture. Oh, you did this. This is the picture of that picture. No. Without magnetic field, I can split this splitting. I cannot do it. But important one has to remember is Keplerian to sub-Keplerian transition, and the fact that the excess angular momentum is taken out by blobs and the winds. I think Leib recognizes that this is a very important thing.
Let me repeat the comment I made in the lecture. It's not aggression, the comment. The internalization is possible to consider forming as a creation separate from the total. No, I
yes, of course. But this solution, the second one, that 1992 I mentioned, that one I think includes the effect. Radial flow was calculated consistently. In 1990 I took the radial flow. No, but no, we understood, and then we yeah.
Another comment or question? Okay, we have a coffee break now, and we have to be back at 11:45.